Hello students, in this video we are going to study objective questions from chapter number 3, Theory of Equations. Very simple chapter. So before learning the objectives, what you have to do, go through all the results, learn the concepts, then do the sums. You can find it very easy. Not only the book back questions, you can answer any question. Mainly you concentrate the areas. For board examination, certain areas you won't give much importance, right? Rational root theorem. But when you prepare objectives, don't leave anything. Okay, Descartes' rule, rational root theorem, all these areas give more importance. Okay, now let's start with question number 1. The first question, very simple one. A zero of a polynomial. One polynomial is given, x cube plus 64. You know the degree is 3, so you know there are 3 roots, right? But in the question, a 0. So 1 0 you have to say, right? So equate with 0, you are getting x cube equal to minus 64. That is x cube is equal to minus 4 the whole cube. When you compare, you are getting x is equal to minus 4. So that is one of the 0. So the correct option is 4. Next one is see. F and G are polynomials. F and G are polynomials. F and G are polynomials of degree m and n. Degree m and n. F degree m and G degree n they set. F composition G. F composition G, that we take it as H. They are asking what is the degree of H. You know the degree of F. You know the degree of G. They are asking that what's the degree of F composition G. So please we take a small example. Suppose F of x I am taking it as say x cube. G of x I am taking it as say x power 4. Instead of m I am taking 3 and n I am taking 4. Let us find F composition G of x. That is f of g of x, right? F of g of x. That is f of, what is g of x? X power 4. Substitute this in f. What is f? X cube. X is actually x raised to 4. So you are getting x power 12, right? You are getting x power 12. 4 into 3. 4 into 3. That 12 you are getting 4 into 3. Because a raised to m into a raised to n, power n is a raised to mn. So but instead of 4 and 3, there we have what? M and n, right? So the degree is 12. The 12, how you are getting? 3 into 4. So for this question, it must be the product of the degrees, m into n. So the correct answer is mn. So remember, f is a polynomial of degree m and g is a polynomial of degree n. Then the degree of f composition G is just to multiply the degrees m and n. Now let's move on to the third question. Please listen to that question very carefully. A polynomial equation in x of degree n has how many roots? Please listen very carefully. Suppose the degree is n, definitely the equation has n roots, right? Quadratic equation, 2 roots will be there. Sometimes roots may be real and distinct. Roots may be real and equal. Roots may be imaginary. Same way, if the degree is n, n roots will be there. Sometimes the roots may be real. Sometimes roots may be complex, right? Or roots may be imaginary. Roots may be real, roots may be imaginary, it may be 0. But one thing you have to remember, the difference between imaginary root and complex root. Imaginary means I should be there. Root of minus 25 plus or minus 5i, right? If I is there, that is called imaginary root. But complex number we study. Complex number means it is of the form a plus ib. Real part is there, imaginary part is there. If that imaginary part is 0, we call it as pure real, right? That is also comes under complex number only. If the real part is 0, that we call it as pure imaginary. So complex number, it contains both real numbers and imaginary number. Okay. So please listen here. A polynomial equation in x has of degree n has n roots means okay, it is correct. But n distinct need not be. Some roots may be even equal, right? N roots are there. Distinct, because that word we cannot take that as answer. N real roots, we cannot say. Some roots may be even imaginary. So this you cannot take, this you cannot take. At most one root. At most one root means maximum one root. 1 or 0. So that is not possible because there are n roots. So n complex roots. Already, so only thing you have to understand, actual meaning of complex number. It includes real number also. Real, imaginary, everything together only complex roots. You know, in Descartes' rule, you study positive real roots, negative real roots, 0 is a root or not, then imaginary. Everything together we say complex root. That is the right option here. Question number 4. Alpha, beta, gamma are the roots of this polynomial x cube plus px square plus qx plus r. So first compare, check whether is it in the correct order. Sometimes they may change the order, you have to be very careful on that. Okay, it is in the correct order. A value 1, B value P, C value Q, and D value R. You know how to find sigma 1, taking one at a time, meaning alpha plus beta plus gamma minus B by A. That is minus P by 1, so it is minus P. Then sigma 2 plus C by A, right? Minus, the next is plus. Sigma 3, taking 3 at a time, minus D by A. If we substitute C by A, Q by 1, minus D by A, minus R by 1. See what they asked to find here? They asked to find sigma 1 by alpha. They asked to find sigma 1 by alpha, meaning 1 by alpha plus 1 by beta plus 1 by gamma. With proper understanding you learn. Sometimes even in 2 mark they'll ask these questions, right? So don't mug up the objective questions. Suppose 2 mark question, compulsory question if they ask. If you know the method how to do, you can score mark very easily, right? Now we take LCM here. What is LCM? LCM is alpha, beta, gamma. Here alpha is there, write the other 2 letters, beta, gamma. Second time beta is there, leave that, alpha, gamma. Then gamma is there, you write alpha, beta. Actually the numerator is sigma 2. Taking 2 at a time, denominator is sigma 3. Sigma 2 is Q, sigma 3 is minus R. So the answer is minus Q by R. Minus Q by R. That is option number 1. Now let's move on to question number 5. Listen carefully. According to rational root theorem, so you must know what is rational root theorem, right? Suppose a polynomial equation is given. Suppose some 4th degree equation they are giving, x raised to 4, then x cube, etc. Then finally some constant, say here 25x raised to 4, something like this. Suppose p by q, a rational number is said to be a root. P must be a factor of this 16 and q must be a factor of 25. Okay, that is a rational root theorem. Very easy one. So now please listen here. In this question, according to rational root theorem, which number is not possible? Rational root theorem itself, it doesn't give the exact roots. Just we can guess these are all the possible roots. So according to rational root theorem, which number is not possible, they ask. See, so p by q is a root, means p must be a factor of minus 5. P must be a factor of minus 5. What are the factors of minus 5? Plus 1, minus 1, right? Plus 1, minus 1. Then plus 5, minus 5. So P is any of these values. Then Q is a factor of 4. Factors of 4 are plus 1, minus 1, plus 2, minus 2, and plus 4, minus 4. So P by Q. Now please listen here. Minus 1. How you are getting minus 1? Minus 1 by 1. P by Q. Minus 1 by 1. It is possible. 5 by 4, yes, here we have 5, here we have 4. 5 by 4, it is possible, it is possible, it is possible. 4 by 5, 4 is not here. 4 by 5 is not possible. Okay? Last one, 5. 5 means 5 by 1. 5 by 1, that is also possible. Only thing not possible is what? 4 by 5. So that is the right answer. So 4 by 5 is not possible. So third option is the correct one. Now let's move on to question number 6. The polynomial x cube minus kx square plus 9x has 3 real zeros. 3 real zeros if and only if. Please listen very carefully, students. Nature of roots we studied. Roots are real, right? That we know for quadratic equation. Quadratic equation, nature of roots are real. When we say the roots are real, discriminant is greater than or equal to 0. When it is greater than 0, real and distinct. Equal to 0, roots are real and equal. In both the cases, roots are real, right? So the roots are real means discriminant b square minus 4ac greater than or equal to 0. But That is for quadratic equation. Here what is given? Cubic equations. But please listen, what is common here? X is common. Take that x outside, you will get x square minus kx plus 9. You are getting a quadratic now. So when you solve x, if I equate with 0, one value x equals 0, that is a real root only. This quadratic has real roots. You are getting another 2 more. We want that 2 roots also as what? Real roots. For that discriminant b square minus 4ac greater than or equal to 0. B square means minus k square. Minus k square is k square. Minus 4 into a value 1 into c value 9 greater than or equal to 0, or k square minus what you are getting 36 greater than or equal to 0, or that is k plus 6 into k minus 6 greater than or equal to 0. Okay, so when you say it is greater than 0, the roots lies outside. Okay, so you are getting 2 values. Your 2 values are plus 6 and minus 6. Sorry, or you say modulus of k, the values are 6, but greater than or equal to means outside plus 6 and minus 6. Plus 6 and outside, only this portion. So you have to say modulus k is greater than or equal to 6 is the correct answer. Okay, modulus k greater than or equal to 6. Third option, no, that is only equal, greater than given, but the correct answer is greater than or equal to also, because root may be even 0. Okay, now let's move on to question number 7. Look at the 7th question. The number of real numbers in 0 to 2 pi. So the interval is only 0 to 2 pi. How many solutions are there for this one, right? So you know trigonometric equation has infinite number of solutions, right? But here the question is, how many real numbers satisfy this? And the number must lie between what? 0 and 2 pi. 0 is included and 2 pi also can be included. See, what is the equation? Sine raised to 4x minus 2 sine square x plus 1. So equate that with 0. It is a quadratic equation. Similar question you have in x power 4, x square, like that, right? For 2-mark question. This question they can ask as a 2-mark question. So take x sine square, then sine raised to 4. So take sine square x as t. Sine square x, you take it as t. So this will become t square minus 2t plus 1 equals 0. It is a perfect square. T minus 1 the whole square equal to 0, or t equal to 1 you get. What is t value? Sine square x. So sine square x is equal to 1. So when you take square root, sine x is plus 1 or sine x is minus 1. Please listen, students. Very easy method to do this. For 90's multiple, 0, 90, 180, 270, 360. 0 to 2 pi only given, right? For sine, the values always lies between the 90's multiples. It take only 3 values. 0, minus 1, plus 1. Like a simple pendulum. 0, left side minus 1, then plus 1. Suppose the first value 0 means, then it is 1, then 0, then minus 1, then 0, then 1. Simple pendulum, how it swings, like that. So easily you can remember that. See the values. What is sine 0? Sine 0 is 0, sine 90 is 1. That too already you know, right? See the simple pendulum. First it is in 0, that swings to 1, then it will come back to 0, then it goes to minus 1, then come back to 0, etc. Any number of terms you can write. Okay? See the question. Sine x is 1. Sine x is 1. Sine x 1 means the value is pi by 2. So x is equal to pi by 2 is one answer. Then another one, sine x equal to minus 1. Sine x equal to minus 1. The value is 3 pi by 2. So x is equal to what? 3 pi by 2. This is one of the easy way to learn. So how many solutions are there? You are getting 2 solutions. Okay, these are the 2 solutions. Now let's move on to question number 8. See the 8th question. One equation given, x cube. One polynomial is given, plus 12x square plus 10ax plus 1999. One polynomial, I'm taking it as p of x, has a positive 0 if and only if. See, Descartes' rule you must know. So given polynomial is p of x, you see how many sign changes. First see that is it in the correct order, right? Ascending or descending order. See the number of sign changes, and that is the maximum number of positive real roots. Then you find P of minus x. See how many sign changes are there. That gives maximum number of negative real roots. Then we check whether 0 is a root or not. All these together we say real roots, right? Then the remaining roots are imaginary. Here, if I see there is no sign change, everything plus, but there is an unknown a. A may take any value, right? It may be positive or negative or 0. So if this definitely has a positive 0. It has a positive 0 means there must be a sign change in P of x, right? So this is positive, this is positive, this is positive. So only thing you can make a value some negative value, right? So when you put a is negative, this part will be negative. Then there are two sign changes, positive to negative, negative to positive. So the maximum number of positive real roots is what? 2. So definitely has a positive real root. So for that case, a must be less than 0. So for 8th question, third option is the right answer. Now let's move on to question number 9. See this question. A polynomial has, see what's the polynomial given here? X cube plus 2x plus 3. X square term is missing, no problem. The available terms should be in the correct order, right? Okay, so everything positive, so no change in sign, right? P of x, there is no sign change. So maximum number of positive real roots, 0. Then P of minus x, you find P of minus x, wherever x comes, you put minus. So minus x the whole cube, it is minus x cube. 2 into minus x, so it is minus 2x plus 1. So see the number of sign changes, negative, negative, the negative to positive, 1 change. So you can say the maximum number of negative real roots is 1. Check whether 0 is a root or not. For that, wherever x comes, you put 0. You are getting 3. It is not equal to 0. So 0 is not a root. So adding all these gives you real roots, right? If you add all these, you are getting 1. So that means maximum number of real roots is 1. That also negative real root. No positive real root here. Okay. The remaining roots are imaginary. The degree of the given polynomial is 3. So you are supposed to get 3 zeros. Only 1 real root. So the remaining 2 are what? Imaginary roots. Okay. So now please listen. Now we see the options. So first don't see the options and check. Go through, find out everything. Now we see which option is the right one. 1 negative. Yes, 1 negative and 2 imaginary. No. Maximum number of negative roots 1 and 2 imaginary roots, right? Yes, you are getting 2 imaginary roots here. 2 imaginary roots and 1 negative root. So that is the correct answer. So look at the other options also, why they are false. 1 positive, no. 3 real zeros, no. There is only 1 real zero. No zeros, no. So the first one is the right answer. Now let's move on to the last question, question number 10. The number of positive zeros of the polynomial, one expression given. See what is the expression given here? NCR minus 1 raised to R x power r. What's the question? Number of positive zeros. So how many sign changes are there? Here r variation is 0 to n you are giving, right? R variation 0 to n. 0 to r is equal to 0 to n. See, I am taking some number I am giving, say instead of n. Easy to understand. I am taking, say, n is equal to 3. So 0 to 3. First I put 0. Please listen here, this is always positive. NCR is always positive. X power r also always what? Positive only. So only thing it depends on minus 1 raised to r. It only gives the sign here, right? So first time you put r equal to 0. So any number raised to 0. When you put 0, 1, 2, 3. These are the values you give for r. Now let us see the sign. When I put r equal to 0, minus 1 raised to 0. Any number raised to 0 is 1, so it is positive. When I give 1, minus 1 raised to 1, minus 1 raised to, so it is negative. When I give 2, minus 1 square, even power, negative. Sorry, positive, right? Minus 1 square. Then minus 1 power 3, odd power, so it is negative. See how many sign changes? 1, 2, 3 sign changes. When I give 3, 3 sign changes. When there are 3 sign changes, number of positive roots, maximum number of positive roots is what? 3. Maximum number of positive roots is maximum number of positive real roots equal to 3. But instead of 3, we have n here. So the maximum number of real roots here, maximum number of real roots number of positive real roots is equal to n. So, maximum number only n. So, number of real roots, exact number of real roots, it is either n or less than n. Either n, the value is n, or it must be equal to n or less than n. So, less than or equal to n option is there, but there is no such answer, right? Less than or equal to n is not given. Less than n, equal to n is given, but as per the book answer, they given n as the answer, but you are supposed to guess less than or equal to n, and you take it as what? Maximum number of positive real roots is n, so you take the answer as n. Okay? So hope you understood all these things. So we'll continue in the next session.